Hello everyone. Today's little shortcut through code is going to be an explanation of how we take a TensorFlow agent model and make it accessible from TensorFlow. TensorFlow agents is a great library for building up tools that allow you to train reinforcement learning models using TensorFlow, but some of the helper operations get in the way from providing a clean interface to a C++ code. What I have is a model that lets me train a actor network, which tells me a probability of which I should take a certain move given a certain state, and be able to predict for a certain graph, in our case, what edges should we add. And that in Python looks fairly easy, but you may note there are a lot of these helper classes that aren't available in C++, so I need to get rid of them. So what I'm going to do is create a version of this actor network, which is the one that takes a graph and predicts a probability that I should add certain edges to it, and renders that into a form readable by the TensorFlow saved model format. So we have to do two steps in particular to make that happen. We're first going to go to my definition of this actor network, which is here. You can see this is part of my GCPN actor network, and add in a TensorFlow function. So a TensorFlow function defines very simple interfaces to a particular TensorFlow module class, where a module defines a network or a computation graph, all the parameters that go into it, and different ways of interacting with those parameters. So what I've created here is a function that, given the descriptions of my graph, provides them in an import format that I can use with my method within this object that computes logits. Logits are log probabilities, which are the outputs that I want. So first I've got this function. The second thing I do is I write a simple helper class to save it into a format accessible from C++, the so-called TensorFlow saved model format. All I do is I create a specification to define how I want to interact with this interface. You can see here I'm calling this getConcreteFunction method with some example input data. And what that's going to do is create a refined version of this computation graph that works with a specific size of inputs. That is very important because it's going to allow TensorFlow to make some optimizations to run that graph faster. Once I have the specification, I call TensorFlow saved models to save my actor network to a specific directory, defining the entry point function that I want with the input shapes that I desire so it can run very fast. So let's show you how all that works. Let's go back to my test case. I've got a version here where we're going to run this code line by line, and these are the tests that I used to make sure it worked. So first thing I do is I make my actor network, and I'm going to call that saved model function. So you note what it's done here is it's going to compile a version of that evaluate function into a format that will save to disk easily, and it'll go ahead and do that. So let's load it back in. Now you can see I've got a copy of the model, which is as a loaded model object. So this loaded model does one thing. It has a signature function called serving default, which is that evaluate function, and you see it takes in these particular shapes that I need. So all I'm going to do is take that object now, and I'm going to call the evaluate function. You can see here I'm calling it with some example inputs, and that runs in TensorFlow in a couple seconds, and it produced this big multi-dimensional array, which will give you a little snapshot of. You can see that there are no probabilities of adding edges to the first node, but you can see that there's a very small probability that I should add this one bond in this particular direction. Now the good thing that we did in this test case, which you should always do, is I computed the output using my saved version of the model. I'm going to do the same thing with my original Python version, and here I can run and see that they give me the same results. So I'm going to finish running that test passes, and I can verify that everything worked the way I wanted it to. I could take my model, I could save it to disk, load it back in, run it, and get the same result as the Python version without having to use all of those lovely TensorFlow agent Python helpers. So that's our tutorial for today.